All right, so in this picture, we notice up top that there are two given. Measure of angle 2 is equal to measure of angle 3. That's marked as arcs, single arcs in the picture. And there's also one other given that's not marked in the picture, that the measure of angle AXD is equal to the measure of angle AXC. I'm going to go ahead and mark that in the picture. I'm going to use double arcs because it's a different angle. So AXD, here's A to X, which is the vertex, to D. Okay, so from A to D. So I'm going to go kind of a big, broad double arc out here so I don't cover over any of the numbers. But that's angle AXD. It says it's congruent to angle AXC, so it would be down here. So we know that those two angles are congruent to each other. Okay, a good strategy, and this proof is partially filled in for us already. So I'm going to try to locate those two given statements. Right away, before I get lost, I want to make sure we include both of them. If we were writing our own proof, I usually just give those as the first two steps. So measure angle 2 equals measure angle 3. That doesn't show up until step number 5. So I can go ahead and write for number 5 that it's given. That'll save us a little bit of trouble later, perhaps, if we're trying to figure out why in the world we could say that. That was just one of the things that was given to us. Additionally, AXD, AXC, that's step 1. So reason number 1 was also given. And then I want to point out to you where it says prove. This is our end goal. This is going to be, should be the last thing that we say. So that should actually go into this last spot down here. I'm going to wait to write it in there, but that should be our last thing. Unlike a given, though, we cannot write, you can't write prove or proven or something like that down here. We actually have to figure out what allowed us to get from step 6 to step 7, and that's what we'll write for that step. But we know that that's when we end. We end at that point. Or the whole goal is to show that those two angles are congruent. So let's go through. So we got number 1 done. And number 2, we have to fill in the blank. They tell us we're using an angle addition postulate. And so we should remember from chapter 1, angle addition postulate is a whole big angle, in this case AXD, this top one, is made up of 2 pieces. The 2 pieces here, we're going to go ahead and use numbers because that's what they use the rest of the way through. Angle 2 and angle 1 are the 2 parts that made up the big angle. So I'm going to say it equals the measure of angle 1 plus the measure of angle 2. Then they ask us the same thing in step 3 about angle AXC. AXC is the one down below, so it's made up of the angle 3 and angle 4. So it equals the measure of angle 3 plus the measure of angle 4. Then when I get to step 4, I see a lot of numbers. 1 plus 2 equals 3 plus 4. We just got done talking about 1 plus 2. And we said 1 plus 2 is equal to measure of angle AXD. And if I look up at the step number 1, they had measure of angle AXD up there. So I'm able to take and do substitution to put 1 plus 2 in place of AXD. Now, you might notice that on the right side of the equation, and in step 4 they're putting it on the left side of the equation. That's kind of unfortunate because they actually have slid 2 properties in here. They snuck 2 in here. We probably shouldn't have switched sides, but since we're not making our own problem, we're just kind of working within the context of what's there. So we're gonna ignore the fact that it's on the other side of the equation. That's okay. And the same thing happened with 3 and 4. We've said 3 plus 4 is equal to AXC, and in statement number 1, AXC was the other side of the equation. So I was able to plug 3 plus 4 in there. So I could replace and say that measure of angle 3 plus 4 is equal to measure of angle 1 plus 2, which is really what number 4 is saying, just in the opposite order. So all I did to get to step 4 was to use substitution. I did it twice, and technically I also did the reflexive property since it switched sides. But we're going to just call it, I don't know what I wrote, substitution, POE. Substitution property is what happened there. So it's a combination of steps 1, 2, and 3 all together making step 4. And then in step 5 was given. Step 6, they actually didn't really give us enough room here. There's a blank for a number, and then it's supposed to be an equal sign, and then it's supposed to be the measure of angle 3. I don't know if I can fit all of that in. I might just write this one over again. So measure of angle 1 plus the measure of angle blank, we're going to figure out what that is, equals the measure of angle 3 plus the measure of angle 4. That's what that was supposed to say. It almost said that, but not quite. So we need to figure out what that something is. So I would compare this line back to line 4. So 4 and line 6, they both start with measure of angle 1. And then it went to 2, but we've got a blank here. Continue on the other side of the equal sign and went 3 and 4. They're both there. So the only thing that's replaced is 2. And we know we're using the substitution, so we must be replacing 2 with something. What can we replace angle 2 with? We see in line 5 that measure of angle 2 is equal to measure of angle 3. So I can substitute the 3 in place of the 2. So it says measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. Now, it doesn't tell us anything about our next step. It doesn't tell us the statement nor the reason. But because it's in a chart here, we can see that this is the last step. And we know what the goal of the proof is to prove that measure of angle 1 equals measure of angle 4. So I can conclude that that's what I'm supposed to put in this line. And I just have to then figure out how in the world do I get there. So from line 6 to line 7, I have to figure out what happened. Well, I see that both 6 and 7 have a measure of angle 1 on the left side. And they both have a measure of angle 4 on the right side. What's changed is that in step 6, both the left and the right side had the measure of angle 3, and that's now gone. Since it was in both places, I could subtract the measure of angle 3 from both sides. And that's exactly what happened to get to step 7. So I used the subtraction property of equality. Okay, so that concludes example number 1. Below that, this isn't super helpful, this small section here, but it does introduce something that will become somewhat important. Talks about what a theorem is. We'll have theorems throughout geometry. It's just a statement that can be proved, so we can write a proof for it. And really, they're shortcuts. Once it's proven, you can just use that theorem in the future to shortcut and jump right to that conclusion. You'll see those throughout geometry, so we'll get back to that. And then it gives you 2 theorems here, theorem 2.1, theorem 2.2. I don't care about the numbers of the theorems. Ultimately, these are not theorems we're going to use in this context a ton. But all it's really telling us that the properties of equality, specifically the reflexive, symmetric, and transitive properties of equality, are also true about congruence. So we can also have properties of congruence instead of just properties of equality. So we'll have POCs in addition to the POEs we have. And that's going to become more important later, not so much in today's section. So let's jump now to example number 2. And we're going to fill out this proof. Notice this time there's only one given. Ray BD bisects angle ABC. That's listed as step number 1, so we can give our reason as given. And then step 2, they're wanting us to apply what we know about an angle bisector, the definition of an angle bisector. What do we know about an angle bisector? Well, we've learned last chapter that an angle bisector divides the angle into 2 congruent pieces. So that helps us know that angle 1 is congruent to angle 2. That should be my step 2. Angle 1 is congruent to angle 2. And then, step 3, they want us to apply the definition of congruent angles. What does it mean for angles to be congruent? In step 2, we just said 1 and 2 are congruent. What does that mean? Well, congruence means that their measures are equal. So now I'm going to put an M in front of both angle signs and switch it to an equal sign instead of a congruent sign. So it looks very similar to step 2, but now it's an equal sign with measures. Really, this is helpful to know. Anytime that you want to switch into an equal sign away from a congruent, or vice versa, we'll use a definition of congruent angles if it's an angle, or segments if it's a segment. So that allows us to kind of toggle back and forth between congruence and equals, depending on whether it's a property of congruence or a property of equality. Okay, step number 4. Measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC. Let's look at the picture. 1 plus 2 add together to make the whole angle ABC. Well, that's an angle addition postulate again. We just had that in the previous problem, 2 of them. Angle addition, you'll see that I'll use some abbreviations here. Postulate. The 2 small parts add together to make the whole thing. Number 5, we see that they must use substitution. So I go over here and I compare line 4 to line 5. It's all the same except for a blank. So we're supposed to be replacing 2 with something. What can we replace in place of 2? Well, we previously said the measure angle 2 is equal to the measure angle 1. So I'm able to substitute 1 in place of the 2. And then you see line number 6. It says to use distributive property. That doesn't make sense. It's a stretch. Maybe you could think of this as distributive, kind of, but you can kind of work backwards from distributive. I would rather switch properties, so I'm going to cross that out. You can do it. It's not the way I want to think about it. So instead, what I would do is I would look at the left side. I already know what the goal is, and they've kind of used a symmetric property too and kind of switch sides. I'm not going to do that. But really I have like terms on the left side. Measure of angle 1 plus the measure of angle 1. So it's 2 of those. So I can write that as 2 times the measure of angle 1. Because they're like terms. And it equals the measure of angle ABC. So for my reason, all that was adding like terms or simplifying. So I'm going to switch it to simplify instead of distributive property. And that was the last statement of my proof. It doesn't exactly state what the proof statement says, just because the ABC is on the right side instead of the left side. But I don't really, I know I could switch those with the reflexive property. I'm content with this because it means the same thing. So at that point, I have completed the proofs. The worksheet, the backside will be due